Hello, everyone, and welcome to today's webcast on data movement and transformation in AWS. We can start with taking a quick look at today's agenda. So it's a pretty straightforward of an agenda, as you can see. We'll start with some introductions to myself, to Thorogood, to AWS. And there's a lot of interesting topics on data engineering and data transformation within AWS that I want to try to cover today. So I'll try to keep intros pretty brief. From there, we'll look at general data transformation patterns, which will be an important input as we start to think about the right tooling and the right architectural design for this within AWS. And finally, we'll focus in on the main topic for today, which is AWS's offerings in this data engineering and data transformation space, including some live exploration of a sample architecture that transforms data in a couple of different ways. So like I said, we'll get started with introductions. My name is Scott Stieritz, and I'm a data and analytics consultant at Thorogood. I'm based out of the US, and I've worked on a number of data engineering and data transformation type initiatives across industries, including in AWS tooling. So I find this whole topic today pretty interesting. I'm glad to have a chance to talk through it with you all today. As far as Thorogood, Thorogood's an independent specialist data and analytics consultancy. So within data and analytics, our consultants at Thorogood are experienced across the areas of data engineering, data visualization, and data science. And our services similarly span the breadth of this data and analytics space, everything from architecture design and implementation to specific solution design and development to hands-on advanced analytics and data science services, through to things like user empowerment and training in key data and analytics topics for the people in our customers' organizations. Now, we're a global organization, so the company is based out of London. I'm joining today from the US, where we have offices in both Philadelphia and Boston, and we have other offices globally in Singapore, Sao Paulo, and Bangalore. I mentioned that we're an independent consultancy. So we're therefore not tied to one specific technology or one specific set of tools. Rather, we have experience across a range of technologies within the data and analytics space, which allows us to understand the business goals of our customers in combination with experience in the technical possibilities to identify the optimal business solutions given business case at hand. And I've put just a sampling of technologies that we commonly work with, among many others, up on the screen here. So while we're certainly AWS consulting partners, we're also partners with and have experience many of the other tooling or platforms you'd commonly see in these types of data use cases. So like I said, I would keep introductions pretty brief. From here, we'll look at some high-level data transformation patterns, some high-level architectural patterns that can support data engineering activity. So if we think about an organizational data architecture, we'll of course start with our data sources. So those could be things like operational systems, maybe flat files, which could be extracts from systems or generated manually by people within our organization. We might have some cloud sources, which could be coming from third-party data providers, could be coming from other places externally, could be coming internally from software as a service type applications. Anyway, variety of sources that we might want to use and to help drive some data insights within our organization. And a lot of data architectures, especially those that are data lake centric, will have some sort of data storage and processing layer. The data from our data sources will be brought into that layer. And a pretty common pattern is to bring that into, call it a bronze or a raw layer, something that stays pretty true to the format and structures of the data as they had existed within those sources. And from there, we'll have some more layers within this data storage and processing space where our data gets a little bit more refined. Maybe we do some cleansing, maybe we join it up with other data sources to start getting closer and closer to something that's going to support actual business cases. Beyond that storage and processing layer, we may also have a semantic layer where the data is being specifically modeled for individual reporting use cases. And that could be a physical layer like databases or a thin logical layer, something like that. But anyway, data models to support reporting. And probably some additional architecture that I've added down at the bottom of the screen here, just something to represent maybe some business analysis or some data science, some advanced analytics type tooling, which probably wants visibility into data across the maturity or life cycle of that data within our architecture, to be able to, in some instances, pull some raw data and use that for certain analyses, and others maybe be able to connect to some of the more enriched and prepared data. And we'll also want to be able to write that back, as we can see the arrows going back into that like data lake portion, so that not only the specific business case, but other business cases down the line can pick up the results from those analyses. Now, our topic for today is data transformation. And as you can imagine, within this architecture, there's a number of different areas where data transformation might occur. So I put a first one up on the screen of just between the layers within our data lake, we're going to have some transformation, which is going to be some cleansing, some joining of data, some preparation of that data for business consumption. We'll probably have further transformations sitting between that data lake and our semantic layer to prepare the data to be modeled in the right ways that support that reporting, and probably also some transformation down in the left-hand side. We might call it data preparation, we might call it feature engineering, we might have a number of different names for it, but data that we are preparing for specific analyses that we may look to run. So anyway, that was a high-level view of the architecture, and I will say that the architectures across organizations can vary in different ways from what I had on the screen. Maybe there's different layers or named differently or different numbers of layers, or, how that semantic layer within the data lake or how that semantic layer is designed might differ. But those types of structures are generally pretty consistent across data architectures. But as we think about specific patterns within that architecture or specific tooling, we might want to have a couple questions in mind that will help drive some decisions in those areas. So I've put just a few of those sample questions on the screen here. For example, who are my expected users and what are their skills? So having the latest and greatest technology is great. It's always nice to have, but it really can only bring us any value if our people can get value out of those tools. So we want to make sure there's good alignment between the skills that we have in our organization and the skills that are required in order to use those tools, or at least alignment between skills that are on our strategic roadmaps of things we may be trying to acquire within our organization over time. Another is, what are my essential points of technology integration? So again, it's good to think about what is possible within tools out there, but we want to make sure they integrate well with the rest of our data architecture. So if that's what are we using for our data lake, if that's what are we using within our source systems, we want to make sure that the tools that we're picking here and the design patterns that we're putting in place are connecting up well with the other pieces that are in play. We also might want to understand data formats and data volumes, probably some other things about the data, just to understand like what functionality specifically is going to be required from this tooling. Also might want to consider data refreshes and latency as we consider things like physical versus logical or virtual layers, as well as performance required downstream, which is probably the opposite consideration. So thinking about when we might want to write out data versus just hold transformations as a virtual layer for some improved performance, for being able to more quickly read those transformations, not need to repeat those transformations every time we want to see the more enriched data. And there's many more beyond just the few that I've put on the screen, but those lead to, again, a non-exhaustive list of some design considerations. So perhaps based on the skills within our organization, we might want to be thinking about code first tooling, where we're going in and scripting in different like data engineering languages and frameworks, versus low code tooling, where it might be more accessible to more people throughout the organization. Probably some benefits around like repeatability or consistency of development in those types of low code tools as well, or physical or virtual layers, which I was mentioning on the previous slide, of thinking about when we want to write out the data or have the data physically exist within one of those layers versus just hold those transformations as virtual transformations, ones that are run each time we want to query the data, which can potentially improve latency. We can get a little bit more of a live look at our data versus needing to wait for the next refresh, but some impacts on the other end in terms of query times and needing to repeat those transformations. and some more like server or serverless functions as we think about, availability of the tooling and how often it's going to be used and whether or not it needs to scale, or if we have pretty consistent demand from this tooling, platform native versus third-party tooling. So think about, and similarly on proprietary or open source tooling, are we really bought into one set of tools and we like the integration, we like the way that all those tools can talk to each other? Or are we more planning for something that's a little bit more modular, something that we might be able to copy into other tools if we want to change up our tooling in the future, something that could span different cloud platforms if that's in line with our organizational data strategy? So anyway, a number of different design considerations that we might think about as we start going into an exercise like what we'll see coming up of thinking about the offerings within AWS and which are right for our organization. So like I said, we'll now take a look at some of those offerings. What tools can we use for data transformation and data engineering within AWS? And I've started by just putting some on the screen here so we can start talking about them. We have things like AWS Glue, which is an ETL tool, kind of the main ETL tool within AWS, built on top of Spark, has a number of different pieces of functionality in there. So that core ETL engine, as well as data cataloging functionality, lots of good integration with other AWS tools, and a more recent addition to that group of Glue Data Brew, which is a UI-based tool that allows us to interact with Glue a little bit more modular, some pre-built types of transformations that, again, can make this like Spark-based ETL a little bit more accessible to others within the organization. We have things like EMR, which allows us to use open source big data frameworks in order to transform our data. If our architecture is a little bit more data warehouse focused, we might consider using Redshift and Redshift Spectrum for connecting to and transforming that data in order to bring it into the warehouse, as well as transforming within the warehouse. We have Athena, which gets a little bit more toward that virtual or logical layer that I was mentioning earlier, which is serverless querying of like relational querying of data that sits within a data lake. So kind of providing that virtual relational layer sitting on top of the data lake that allows for querying by users, by reporting tools, a number of different things. And then maybe some more niche data transformation tooling here. So Lambda, which are serverless functions, which might lend themselves well to a kind of microservice-based architecture if our organization's set up that way. We have Kinesis, which focuses a little bit more on streaming data. We have SageMaker Data Wrangler, which is integrated into SageMaker, of course, and focuses a little bit more heavily on data preparation, feature engineering to be brought into SageMaker for advanced analytics and data science use cases. So I figured it's interesting to talk about the tools a bit, but it's probably even more interesting to see some of them in action. So I've set up a pretty simple business case here. Let's consider ourselves to be part of a consumer goods company. We're selling some products to a number of different customers distributed throughout the world. And we have data coming from, let's say, our internal sales systems. We have some supply chain data that's tracking our order information and shipment status. We have some customer data, maybe coming from some master data within our organization. And we have a bit of a shared data responsibility model. So we have some central functions within the organization that focus on connecting to source systems, especially big systems that are going to service many of the data analytics needs across our organization, and bringing those into our data lake, cleansing the data a bit, starting to get it ready for people to use downstream, and then maybe some more specific business responsibility in those downstream pieces of thinking about what's going to be needed for individual business cases, enriching the data, preparing it for use within specific reporting initiatives, those types of things. And then from here, we can see some of this in action. So I have this up on my other screen, which I can bring up here. So I've just created an S3 bucket, which is standing in for our data lake. And we can see a couple different layers within the S3 bucket of our bronze, our silver, our gold layers. Within the bronze layer, I've just added in a few files that might be representative of some extracts from a source system, something like that, where we have some sales data over the past couple of years. We have some of that orders and shipment status information from our supply chain team. We have some customer data all sitting within this data lake. And then we can use a tool like AWS Glue here to get into that data transformation a bit. So within Glue, we can have Glue jobs that are structured in a number of different ways, as we can see on the screen. So we could start with the native integrated Glue visual design tool, where we have a little bit of drag and drop type functionality for deciding how we want to transform our data. We could be writing Spark scripts or Python scripts like in isolation. And then a piece of functionality, newer functionality within AWS that I'm pretty excited about is the integration of Jupyter notebooks to sit on top of this Spark transformation. And that's what I have been setting up here, where we have a pretty simple notebook that is connected to a Glue job. And this notebook, I've started with just a couple lines of doing some data exploration. So bringing in a couple of our different data sources just to get a sense for what this data looks like. So here connecting to some 2019 sales data, some 2020 sales data, being able to see what it looks like when loaded into data frames and get a sense for, are these generally aligned? The schemas of these files, can I combine them? And it looks like they are. Looks like they keep pretty consistent formatting across the files. And then I have some code which might look a little bit more like the code that would truly sit in between the bronze and silver and gold layers here within a data lake. So some code to just go through for each of the targeted sales years, load in the relevant sales CSVs and bring them into one data frame. So being able to stack or union all of our sales data. Just a quick check to make sure that I've captured all of the data in here correctly. I'm not losing out any rows. And then writing out some of this sales data into a big unioned Parquet file into the silver layer of our data lake. And again, doing a little bit more of the same, lightweight data ingestion, data cleansing that brings data in from bronze into silver. And then another piece of Glue, of AWS Glue, that's well integrated here is the use of the data catalog. So, within that notebook, I started showing, okay, well, I'm writing some things to silver. I'm writing out some sales data. I'm writing out an orders table. I'm writing out a customers table. But if somebody were to go in after the fact, how would they know what data is in there, where it sits, what the data looks like? So I've also used some of the data cataloging functionality also within AWS Glue, natively integrated here, to create this silver data catalog database here. So I could see my sales information and all of the columns that I have within this sales information, or I could take a look at some of the other tables that are available within the silver layer. From there, I've created those databases, but in order to populate the databases, I've also used some more functionality natively integrated into Glue, which are Glue crawlers. And I've set up this one to specifically crawl through the silver layer of our data lake and basically check each file, look at each file that's in there, pull out the schema, and populate the database with all of the information about the files that are in here. Meaning I didn't go in here and say there is a customers table or an orders table or sales or last refresh or anything like that and tell the Glue data catalog that. Instead, I left that up to the data crawlers to look through and automatically populate that. That way, when I have more data transformation processes in the future to add in some more tables to ingest some new data, I don't need to be manually making sure that the catalog is up to date. I can just go in and trigger this crawler. I could hit run crawler and it will read through and make sure that every table that's captured within that silver layer is also captured within the catalog. Then from there, I mentioned there's that shared kind of data transformation responsibility model within my organization. So let's say the IT team is responsible for bringing data in, getting it up into that silver layer, and they're providing me with this data catalog so I can get a sense for what data exists where. Now, maybe as somebody a bit closer to the business, I feel a little bit more comfortable within a tool like Data Brew, where I can do some more UI-based interaction with the data and kind of prepare it in a way that will help support the business cases that I want to be working on. So I first started just creating a couple data sets which are pointing to the Glue catalog. It's just pointing to the customers table or orders table or sales within the Glue catalog. And then I've created this project called Sales Combined, which might take a minute to provision here, but I've kept the transformations pretty simple, again, just for the purpose of this demo, where I'm doing an inner join between my sales and my order information to pull in information like the order date, the order ID, well, based on the order ID, the order date, the customer ID, so who I'm shipping this to, shipment status, all those sorts of things, which then also allows me to join in my customer information. So based on customer ID, I can get things like the location to where I'm shipping that data, whether that has been shipped or if it's pending or if there's any issues with the data. And now finally, let's say I want to do some reporting on top of all of this. Maybe I want to look at the regions of the world where I am running into some shipments issues. So looking at frequency of shipments in that issue order status by location. But maybe me as a business analyst, I am focused on the US in particular, something like that. So I can connect to that same data catalog. And I should mention, I've also created crawlers and a data catalog database for the gold layer. That way, same thing. As I'm bringing in data, as I'm transforming it, I can have a good view into what data exists and what it looks like within the data lake. So I've connected to that gold catalog, and I can see one file that's in there or one table that's in there that's coming out of this data brew transformation. And it's called Sales Combined. And it's just that sales and orders and customer information. And maybe I want to write a view on top of that, since I'm focused on the US only, called view sales combined USA. And I can run that query, which is just going to define this view. And then I can see this view that now exists. And actually, if I were to go back into the Glue data catalog, I could look in gold as well and see that Athena will auto-populate this view into the gold data catalog. So I can see not only the tables that live within my data lake, but also the views that I've created on top of those tables. I could maybe run another query of just like a select star from view sales combined USA, and I'll just take back the first 100 rows, run something like that, and be able to quickly see all of my data. And now this might be me actually writing this query. This also might be a reporting tool sitting on top of Athena, which is defining what these SQL queries are, which are ultimately being passed back to the data sitting in the data lake. So again, I could then do some analyses like issues with shipments by product or by state within the US or anything that I might want to do within my reporting use case. So as a quick recap of this demo, this was the high-level architecture that we had started with. We'll kind of hold on that business analysis and data science side of things for right now. But the data lake is within S3, within Simple Storage Service, which is just object storage within AWS. We saw AWS Glue, especially the notebook functionality, being used for transformation from some of those early layers of the data lake like bronze into silver. We also saw Glue Data Brew as maybe a little bit more of a business-friendly tool for transformation from silver into gold to start getting that data ready to be prepared for reporting. And then we also saw Athena functioning as that semantic layer, so defining some views within Athena that sit on top of the physical data living within the gold layer that can then be further passed into some visuals that we're building. As far as the Glue data catalog, I mentioned we had built crawlers in Silver, which will populate that data catalog with some of the information of our cleaned and prepared data. And then we could see that I was able to make use of that data catalog within Glue Data Brew in order to create some of those initial data sets. And again, a crawler that sits on top of Gold identifies the data within Gold and can further enrich that data catalog so that when I'm using things like Amazon Athena, I can understand what data is available to me. I can create some views on top of the data. And then I've made this arrow bi-directional here in that the views that I'm creating in Athena can be passed back to that same data catalog for others within the organization to use. So I realize we're running up on time here. And for that reason, I'll share some final considerations or some final things to keep in mind thinking about one of these data transformation architectures, especially in AWS. One is multi-cloud architecture. So a key question is just whether or not this is part of my organizational data strategy. But if it is, I want to be making sure that I'm using some tooling that could connect to sources not just within AWS, but maybe spanning cloud providers, or maybe able to surface insights across different tools in different cloud platforms. And similarly, thinking about a cloud exit strategy. So if our exit strategy might be something as simple as defining all of our transformations within code and using code that's interoperable across platforms. That way, if I ever needed to move to different tooling, then I could just pick up the same code and run it in other tools and other platforms. Or it might be a little bit more complex as we start to think about some of that UI-based, some of that proprietary type tooling supporting data transformations. We also want to think about automated frameworks, especially in earlier layers of the data lake. So any development that we can offload from our teams and just create as some automated transformations that are, say, recognizing file types and converting into interoperable file types, or recognizing common data patterns and doing some common cleansing or transformation that we know we're going to need across sources. So anything that we can prepare for and expect and not need to code out manually each time is going to help us bring more data into the data lake. It'll help us get it more ready for people to use within their organizations. We'll also want to think about good DevOps practices. So let's say integration with CI/CD pipelines for the maintenance and the development and deployment of our data transformation processes. And lastly, some thinking maybe on data catalog integration. So how much value can we get out of these transformations within one of these architectures, unless someone can go into this knowing or seeing, I know what data is in there, I know what the data looks like, and now I will be able to use it. So probably a whirlwind of information, but hopefully this was interesting for everyone today. Thank you all very much for joining today. My contact information is up on the screen, so if you have any further questions or comments coming out of the session, feel free to reach out. And with that, enjoy the rest of your day.